Hey, it's Mark Keane here from Microsoft, and we're here at Microsoft in Redmond at the campus Corp, and it's building 40, this one, which is all Azure networking. And we're here for another ExpressRoute whiteboarding demystified video. This is episode 3. And this time we're here with John Ormond.
Yeah.
Ormond, yes, I got it right. And he's the Mr. ExpressRoute. And we're here at Microsoft in Redmond, and we're going to cover off a whole bunch of things with ExpressRoute, all the latest stuff that's come about since the last 2 videos we did last year.
All right. So, as said, I am John Ormond on the Azure Networking ExpressRoute engineering team. I am not Mr. ExpressRoute. I am one of many Misters and a couple Misses. Yes, there's a lot of folks that make this service happen. I am one of many, but happy to share today. So, I think we're going to talk about
give us a quick
bunch of
overview
features. Yeah, a bunch of features of ExpressRoute. So first, what is ExpressRoute? Customers have an on-prem, and they've got resources in Azure. How do we get there? So internet is an easy option, but it's not something that most companies will run their business over the internet. So VPN is usually the first place that customers will connect their on-prem to their Azure resources. And that's great up until about 1.5 gigabits per tunnel. As you start to grow past that, you'll need to add more tunnels, or you can go to ExpressRoute. So ExpressRoute uses a service provider. Usually, I'll explain the option to not use a service provider, but usually has a service provider in the middle that gives you private connectivity from your on-premises up to Azure. So this would be an Optus or a Telstra or somebody like that will actually either give you an MPLS cloud so you can network all your branches across your geo, or specific point-to-point link services. And this does not ride the internet. It's completely separate. It's dedicated just for your data traffic. So, and it goes from your on-prem up to Azure. Now, this is actually connecting to Microsoft's network, so not even exactly in Azure proper. But once you're connected with ExpressRoute, you can also go to other Azures or even other Microsoft services. So ExpressRoute is connecting you to our network.
What is this part called here?
So this is what we'll spend most of this video talking about. This is the Microsoft Enterprise Edge, or MSEE. This is a physical router that sits in our edge sites. For ExpressRoute, we are in around 55 or 56 of our 160 internet edge locations. So these are places that we're connected with service providers that customers who use that service provider can then ride in. I'll talk about ExpressRoute Direct later, where you can actually plug directly into the MSEE as well.
Okay, while we're on the subject of this, and this is the concept of a circuit, ExpressRoute circuit, did you want to talk about S keys and how they relate?
So these MSEEs, or the hardware devices themselves, many customers and many service providers will use these devices. So the hardware is shared, but we give each customer an isolated path into that hardware. So if we think about the ExpressRoute logo itself, we'll put customer at the top, we'll put Microsoft over here, if I can spell, and then the service provider here.
I always wonder why there's 3 circles on there. Okay.
So it's this
that's what
trinity, if you will,
nice.
that make ExpressRoute, right? Because the customer has to go through a service provider to get to Microsoft. And so the 3 of us are going to be working in our own environments and our own networks. And how do we make sure that we're working on the right thing? If company A calls and says, I have 3 ExpressRoute circuits, and one of them is down, please go troubleshoot. Well, I won't know which router or which port on the router to go look at, because, well, you've got 3 circuits. How do I identify what's what? So kind of in the middle is the service key. That's a service key. So a service key is a 32 character? I don't know, it's a GUID. So whatever that, like 12-4-4-4-8 or whatever that works out to be. But the big, long, ugly number that you see assigned to a lot of objects.
We'll put a pop-up on the screen to explain
show what a GUID is. Yeah. That is the service key. It is basically metadata that it's not really used in the networking on the data plane in and of itself, but it's that unique identifier that lets the service provider know that they're working on that customer's circuit, on the correct virtual circuit. Now, this is actually tied to many objects and attributes of the ExpressRoute circuit, but this is the unique identifier that we will give to the service provider to say, hey, build a tunnel between the customer and Microsoft using your network that ties everybody together. So when the customer talks to Microsoft, they can give us that key. When they talk to their service provider, they give us that key. And then each side can do API call lookups using that service key to get back the relevant information that each side needs to do to build this bridge from on-prem up to Azure.
Excellent. So talking about different areas here, different providers here, or vendors, whatever you want to call them, each different, the customer there, Microsoft and service provider. There's a concept called A-side and Z-side, which you brought up in your talk that you did.
Correct.
Do you want to just cover that off?
Yeah, and that is really nomenclature terminologies for these colo providers. So our MSEE routers don't actually live in a Microsoft data center. They live in a Microsoft space that is leased or rented from a colo provider. So they're in what's called a carrier neutral facility, so that all telcos, all customers can come into this place, and it's a general clearinghouse that everybody can bring connectivity in and connect. So that way AT&T and Vodafone's and Orange can all come into this facility in a neutral manner and conduct business. And that's basically how the internet is built. All the service provider coming together at these certain exchanges and being able to link to each other. So what was the question?
It was talking about A-side and Z-side.
Oh yeah, so A-side, Z-side. So it's their terminology to say, you know, I want to connect to someone else. And so the A side is the person who's making the request, and the Z side is the place that they're going. So
pretty much like customer and then the provider.
So the customer is going to have a cage in the service provider's facility, and Microsoft is going to have a cage as well. Now, if Microsoft made the request, the A and Z would be flipped, but since the customer is always the requester, they're going to say, hey, I want to connect into your Z side. So when we look at Equinix on their portal, the Equinix portal will ask, and all major telcos and exchange providers have these type of portals, where they'll say, where are you, customer, coming from, and where are you going? So you first signify this is where the customer is, and this is where they're going.
Excellent. So, which leads me to the next question. So you've got customer, service provider, Microsoft, but then one might ask the question, you've got multiple customers going over the same piece of wire, so that the concept of QinQ and double take VLANs, whatever you want to call it, and that versus, which is .1Q.
So we have a big router, and this router has ports, and it's fiber, not wire. So this piece of fiber on this port, right, it's a two pieces of plastic plugged into this port. We will assign that to a single service provider. So let's say Optus gets this one. Now, this is connected to another router that's owned by Optus. So we've got this connection, but we want to let all of Optus's customers that buy ExpressRoute circuits use that. So we have to divide this circuit up in a logical manner.
And there would be two of these, right, for redundancies?
ExpressRoute, everything is physically redundant. So yeah, so this would just be the primary side. There's also a secondary side. When we say primary and secondary, that's kind of a misnomer. We run everything active. So it's A and B, left and right, up and down, whatever you want to call it. But everything's done in physical pairs. So looking at the primary side, one port to one port, and then we have to divide this up somehow. The way that most networking occurs, you use VLAN tags. So we start with .1Q, and that's what most enterprise networks on-prem facilities will use. They'll use these different VLANs, and that's just a 4-digit number from 0 to 496. I think that's the way that power of 2 works out, and completely decided by whoever's controlling the network what that should be. Now, because there's a customer and a service provider, we use what's called QinQ. QinQ. Also, 802.1 AD is the actual standard if you want to look that up.
Nice.
So QinQ is actually stacked VLAN tags. So what that means is I will have, let's say 27 as a tag and 1022 as a tag. And the first tag is called the outer tag or S tag, service provider tag. The next is called the inner tag or the C tag, the customer tag. Now, in reality, these are just two .1 queues stacked on top of each other in the header of the packet.
Makes sense.
Now, most customers never see the QinQ. The service provider says customer A is going to be 3, customer B is going to be 27, and customer C is going to be whatever. So the service provider will assign these numbers out based on the customer and the port and everything to make that unique for them. Now, inside of that, the customer may need VLAN tags, and so they will assign the inner tag themselves. And what the service provider often will do is they'll pop off that outer tag, so the customer only sees the tag that they define, and they'll never see that. Now, with ExpressRoute, by default, everything we do is QinQ. Microsoft defines the outer tag based sequentially on this router and this port. So the first customer that comes on is 2, 1 is reserved or native or whatever, and then the second customer is 3, and then 4, and then 5. If customer 3 goes away, the next customer will get 3 back, and that kind of thing. So for every service key, we reserve an outer tag on a specific port.
Sweet.
So if I get a circuit that lands on this port, I may be outer tag 27. If I get another ExpressRoute key on a different port, I may be 2 over here.
Okay.
But every ExpressRoute service key has one and only one outer tag on a specific router pair and port pair.
So this would be layer 2, I'm guessing?
Yes, yeah. VLAN tags are at layer 2.
Layer 2.
Correct.
Awesome.
Yeah.
Okay, so we talked about QinQ connections and sharing the same layer 1 and all that type of stuff with QinQ double tag VLANs. The next thing we need to cover off is BGP in general.
Yes.
So talking about the 2 types is the peering to begin with, and then you've got the advertisements after that.
Yeah. So with these routers, the VLAN tags will set up layer 2. So once I've got all of this in place, I've got my service provider, I've provisioned this circuit, I've told them the inner tag that I want to use, so they've programmed their router to pass that down to me. So if this is the customer equipment, or the customer edge router, once this is provisioned, I have a layer 2 path all the way up to Microsoft. This is where BGP comes in. BGP runs at layer 3. So at this point, I will use, remember this is redundant, a primary and secondary. I'm going to talk about the primary.
Imaginary one over here.
Yeah. I'm going to use a /30, which is 4 IP addresses. The middle 2 are the ones that are usable. Based on IP address standards, the first address is the network address, the final address is the broadcast address, and the 2 in the middle are usable address. So it's a /30, which is 4 IPs. If you are a router person, you will know that you can actually use the 31 on most devices. However, Microsoft has chosen to be pure to the standards, and we will only use a /30 here.
Perfect.
So use a /30, and let's say it's something .0. So that means 1 and 2 will be usable, and 3 will have 0 as the network, 3 as the broadcast, 1 and 2 are usable.
The customer comes first.
Customer is always first.
Because they're the odd ones out.
Yeah.
Well, and then the customers in Microsoft's even.
So of the 2 usable, just the way that binary math works, the customer always gets the first one. So this device would be the .1 address of that /30. And then because you put this in the Azure portal or PowerShell or however you create the peering, we know to go out to our router and program this as .2. So now we have 2 neighbors that are connected over layer 2 with IP addresses that can ping each other. Once you've got that ping established and you establish all of this stuff, then you can bring up BGP.
Which is the peering part.
Yes.
Like a handshake.
Yeah, and this, what we're talking about right now, is both true for Microsoft peering and for private peering. But this is where I'm going to talk about these 2 different peerings, and you'll see how they start to differ. So I'm going to get away from the physical and just talk about the virtual. And probably come to this side. So we've got a customer router, goes up to an MSEE, and then this MSEE can go up to the public cloud, and then it can also go. I use the exact wrong colors if you've ever seen this diagram.
The opposite.
Yeah.
That's okay.
So I remember I said we have redundant routers. We also have redundant BGP sessions. So when I bring up BGP, I have a primary /30 and a secondary /30. That's so that we can have 2 paths up and 2 paths up. If one side fails at any layer due to any reason, you've got the other side. If you buy a 1 gigabit ExpressRoute circuit, we're going to plumb 2 1 gig physical paths in here. So if a fiber is cut, an optic fails, power outage, we need to do router maintenance, things of that nature, we can take down one side, the other is up and running. So it's important to realize we always run active-active. Everything being equal, you could pump 2 gig through your 1 gig circuit because we're running active-active. But yeah, it's designed that way so that even in a case of failure, you still get your fully rated speed. So we have public services up here. These are all public addresses, things like Office Dynamics, PaaS services, SQL storage, etc. in Azure. These are all being advertised down to the customer, so they're able to get to those public services without using the internet. Now, if let's say you've got a storage account that's 131.1.1.1 on the internet, it's still 131.1.1.1 here as well. It's just you have a more specific path to get to it, and you don't need to go out your company's internet edge to get around to that. So all of your traffic can stay on that side. Many of our services are adding firewall features now so that I could take that storage or SQL account and actually turn it off from the internet. So now it's only accessible via an ExpressRoute circuit through this Microsoft peering setup. On the other side, we've got private peering. This is to get to your VNets and your private address space, usually 10.192.168 or 172.16, RFC 1918. And this involves an ExpressRoute gateway that lives here. That ExpressRoute gateway is what helps to translate the physical world to the virtual world. So that's why we need a gateway here. With Microsoft peering, this is more just directly into a public network, so we never need to take it up into that virtual overlay, but the gateway is required to do that on private peering.
So, okay, so let's talk about, you've got the peering, you've got the advertisement, so you get the routing happening and everything else. Now, what if I'm concerned about, I'm a government customer, I don't want my traffic going over, yes, it's a private connection, and I'm concerned about security, I want to make sure it's encrypted. Do you want to talk about this new thing called MacSec?
I'll talk about it in 2 ways. First, encryption end-to-end. With ExpressRoute Microsoft peering, you can do a VPN connection across this. ExpressRoute is encapsulated by default, but not encrypted by default. For some companies, encapsulation is enough. You guarantee separation so that the other customers will never cross traffic. Other customers, regulated industries, etc., need encryption. So to take it to that next level, if you need to encrypt ExpressRoute end-to-end, that's where IPsec tunnels come into play, and you can actually stand up ExpressRoute and then put a VPN tunnel inside of it, and that will take you layer 3 encryption end-to-end.
And I'll put a link to the doc site down the bottom so you can set that up.
Now, if you trust your network and you trust Microsoft's network, but you don't trust the landlord in the middle, right? So normally we have customer, service provider, Microsoft, right? You normally go through the service provider. Well, the traffic has left my network, has gone through a third-party network, and then enters Microsoft's network. That's 3 entities I have to trust. And maybe I don't want to do that. Maybe I would like to cut out that service provider as a data path, right? I still need to be in a colo, but what we have now is called ExpressRoute Direct. And with ExpressRoute Direct, the customer's router plugs directly into Microsoft's MSEE router. So that is a single piece of fiber going from one router on the customer side to the cage and router port on the Microsoft side. So it runs through the landlord's airspace, if you will, but it doesn't go through the landlord's devices. And so that's really important to reducing that threat vector. Now, we take it one step further with the MacSec, and we can actually put encryption at these points. MacSec is a layer 2 encryption protocol or encryption scheme. It only protects layer 2, which means nothing to the right of Microsoft is covered by that point, and nothing to the left of the customer is covered from that point. It is strictly from this one neighbor to this other neighbor. It is only those 2 points, both ends of that fiber, nothing further. If you want to extend it further, it's an entirely different MacSec for each hop, for each neighbor.
Question I had from a customer was, if you want to do layer 2 point to point from one device to another device, can you have another device in the middle?
No. Well, so You can, the customer can, but in this network, the customer would have to control all the keys to the left. With MacSec on ExpressRoute, it's bring your own keys. So these keys live in a key vault that the customer controls, and Microsoft will put them on our side, and then the customer has to use those keys on their side. If you start putting devices in the middle, who's responsible for those keys? So Microsoft can't be, but if the customer had, another router and another router, right, they could start to connect that so that they had MacSec. And we're doing that on our side as well. So when things go cross-region, things of that nature, or within regions, and we're adding more and more MacSec to make each hop an encrypted channel. But right now for ExpressRoute on the edge to customers, you can only be sure of this route, right? That's what you can secure. The nice thing is, with this, if somebody was to break into the landlord and splice your fiber, which I don't know how that would really be possible.
Get through security.
Well, they're in raceways that have thousands of fibers, and they are all yellow or blue or whatever.
Good luck with that.
And they don't radiate like wires do. So I'm not sure how you find the right one. But anyway, even if you did, you would be now encrypted. So on the most vulnerable link, which is outside of their cage and outside of our cage through the landlord's airspace inside the facility, that is now encrypted for that path. So if you trust your own network and you trust Microsoft's network, this is what's allowing pharma, banks, gov entities like that to enter into the cloud now. So that really helps that middle kind of area where they don't have positive control.
Perfect. And we sort of skipped a level. I guess I should have put the bit down the bottom at the top. We'll cover that off now, because MacSec requires ExpressRoute Direct,
correct,
which cuts out the service provider.
Yeah. So because the service provider network has many routers. And so the service provider does not have your keys, and nor do you want to give your service provider the keys, because that defeats the purpose. Yeah. And so since there are many hops potentially through here, you can't MacSec each one. So ExpressRoute Direct, that direct connection is required if you want to use MacSec.
So while we're on the subject of ExpressRoute Direct, do you want to just talk about just briefly the different speeds and the ports and how they work?
So with regular service provider, normal ExpressRoute, if you will, you can have varying ExpressRoute circuit speeds up to 10 gigabits. With ExpressRoute Direct, you can get a 10 gigabit interface, but you can also go up to 100 gigabit interface. So that's pretty massive. And when you do this, remember it's on two routers. So that's, if you're running active-active, is 200 gigabits of capacity that you can push through that.
Nice.
One point though, ExpressRoute Direct is not ExpressRoute. So ExpressRoute Direct is the port on the router. You're basically leasing that space on our router. Once you have that ExpressRoute Direct port, then you put ExpressRoute circuits on top of that. The ExpressRoute circuits are no charge on an ExpressRoute Direct port. So I could have a 100 gig interface and spin up 3 10 gig circuits, a 1 gig circuit. We have some new sizes with ExpressRoute Direct, a couple 40 gig ExpressRoute circuits. So I can reuse that port many times for ExpressRoute. I only pay the ExpressRoute Direct port charge and then data egress charges for all of the circuits. With the exception of ExpressRoute Local, which is a new SKU that we have. So if you get ExpressRoute Direct, say in I'll use the US example of Silicon Valley. If you get an ExpressRoute there, US West is very close to that ExpressRoute location. So we will give egress free to that Azure region if you pick an ExpressRoute Local SKU.
Or even in Australia, we've got 2 MSEs now.
Yes.
We've got Sydney 1, Sydney 2. So you plug into one with ExpressRoute Local, it's free egress coming out.
For that one specific region. Yeah.
Okay.
Now, if you need to go cross-region, well, then you can spin up a standard ExpressRoute circuit and use that to go cross-region. All on your ExpressRoute Direct port. So port is the physical interface on a router, and then you layer ExpressRoutes virtually on top of that.
So just, I guess, another question to lead off to this is ExpressRoute Direct, plugging into the physical ports on the MSEs, then how do you get around QinQ versus .1Q?
So with ExpressRoute Direct, the customer has the choice to call either QinQ, which is what our native is, or to go .1Q. If they just can't handle it or don't want to, they can say, I want everything to be just .1Q. Because we don't have multiple customers on that port, they're buying that whole port, right? And QinQ is to give us uniqueness on a port. Well, the customer's already unique on that port. So the outer tag is superfluous or irrelevant. Now, if they do QinQ, each ExpressRoute will get its own outer tag, and then they can use inner tagging to differentiate in that circuit. But if they don't need that or they don't care about that, they can go .1Q, and just every ExpressRoute circuit they place on there, they define the inner tag and don't have to worry about the outer tag.
Does that mean I could purchase like a port pair off the MSEEs with QinQ and I can become my own mini service provider?
Technically, I suppose you could. It's not really built that way. It's not really charged that way. But yes, I mean, that would give you differentiations. The way that we usually see it working is lines of business within an organization will split that out. But it's got to go back up to a common billing location, security domains, things of that nature. It's not really set up to be multi-customer. Mm-hmm. It is multi-tenanted, but multi-customer, we don't recommend it for that, and we're not set up for that.
Okay, so, perfect. Yeah. And the last one is the Azure side of it. So we talked about ExpressRoute, the bit in the middle, the ExpressRoute Direct versus ExpressRoute. The bit when it comes into Azure, the other part that's fairly new is FastPath, which is not to be confused with FastPath you get from a roller coaster park, and you can skip the lines.
Well, it is kind of like that. So, I know this is the wrong icon, but that's okay.
So customer on this side?
Yeah. So I've got a VNet. I've got this little cloudy Azure bit. I've got an ExpressRoute gateway. Today, because this VNet has a VM on it that's got a 10.0 address, and this MSE lives in the real world. So there's a bunch of people that have 10.1 addresses. So when you tell the MSE, hey, I want to go to 10.1, MSE goes, well, I don't know where that is. So this gateway here actually translates this into a physical address on that unique physical machine that VM lives on. So this gateway is doing that mapping or that routing between this private virtual construct and this physical network down here. So what happens is when the traffic goes up, it comes up, it goes to the gateway hands it off. Now when the traffic returns, and this happens today in normal circumstances, when this thing returns traffic back down to on-prem, it actually bypasses the gateway and goes directly to the MSE. Because this has a unique public address, so it's very easy for this guy to say, hey, go out to that address. But the traffic coming in says, oh, 10.1, I don't know how to do that. So what we're doing now with ExpressRoute FastPath, the traffic will bypass the gateway in both directions. A gateway is still required though, because this is what is maintaining BGP with the MSE and with the on-prem. So BGP is still required, and this is the control plane. We're just moving the data plane out of that path. So the MSE will then, the gateway will tell the MSE, hey, if you need to get to 10.1 for this customer, he is up here. So basically you bypass the gateway, both inbound and outbound. We've always bypassed it on the outbound, but now it's both ways for this VM traffic. Look at the Azure.com documentation, because there are certain services that are not supported with FastPath. If something is not supported with FastPath, that just means it goes through the gateway. If something here breaks, it just goes through the gateway. So the gateway's there. It will, it's still the second string quarterback, but it still has to be there to maintain BGP, but FastPath bypasses that traffic. You take a component out, which is always goodness, right? Simple is better, and taking the gateway out of the path can unlock latency and speed increases.
Excellent. And I think you've covered off pretty much everything we had written down for that, and I think that's all the latest that's come out recently. So we did episode 1 and episode 2 of ExpressRoute Demystified videos with a whiteboard. And today, just to recap, we're here at Microsoft in Redmond, here with John Ormond. And John, thank you very much for that.
Thank you.
Appreciate it.
Yeah.
Next time.
Yeah. Cheers.